Hello, this is our project over stoichiometry. We are doing this for our pre-AP chemistry class.
Stoichiometry comes from the Greek words stoichion, and meaning element, and metron, meaning measure.
These are conversion charts for this aspect of chemistry, and when you use stoichiometry, you must always go back to moles.
The conversions from moles to grams is the element's molar mass. So let's say you have hydrogen. The molar mass of hydrogen is 1.008 grams per mole of the element. If you want to go to grams of an element from moles, you must multiply by the molar mass. So you have 2 moles of oxygen. To get the grams of oxygen, you must multiply by 2. By the mass of oxygen, 15.999.
Okay, so this is our moles to gram example. We have 2 moles of oxygen, and we want to see how many grams are in it. So the molar mass of oxygen is 15.999. So we put that over 1 mole of oxygen, and we multiply. And that gives us 31.998 grams of oxygen. Avogadro's number is the number of atoms in a mole. This number is 6.02 times 10 to the 23rd, or 6.02 e to the 23rd. Assuming you have 100 moles of one element, you would have to multiply it by 6.02 times 10 to the 23rd, which is 6.02 times 10 to the 25th.
So in this example, we're going to go from atoms to moles. We're going to start off with 1 million atom of helium. It doesn't matter which atom you pick with because the constant remains the same no matter which number you go with. It always goes back to this number, 6.02 times e to the 23rd, which is the constant for moles. So, in order to move from atoms to moles, you have to divide by a number, by Avogadro's number. So, 1 divided by 6.02 times e to the 23rd is the same thing as 6.02 times 10 to the negative 23rd. 22.4 liters of an element or solution is equal to a mole. If you have 224 liters of a solution or element, you would have approximately 10 moles of said substance. Okay, this one's slightly different than the last ones because we're going from grams to moles and then to liters. So, how you do this is you start off with grams of C6H12O6. We're going to have 90 of those. Okay, the approximate weight of 1 mole of C6H12O6 is 180 grams. So, you're going to divide this by this. And then the ratio of C6H12O6 to oxygen is 6 moles. So you're going to have to go here, here, then do your ratio. The one you're working with always goes on bottom, and the one that you're going to always goes on top. That's how you will differentiate in further problems. And then the constant for liters from one element to another, or for moles, is 2.4 liters. So you're going to multiply this all together. It comes out to be a total of 67 liters of oxygen.